request Dr. Farooq Arif. He's going to speak on application of smart and immersive technologies for construction projects. Dr. Farooq, floor is yours, please. Dr. Farooq, I can't see. आपको डॉक्टर फरूख मेरी आवाज आ रही है?
Sir, Assalamu alaikum. Thank you very much. Let me start with thanking IIPS for providing me with this opportunity to basically talk about the topic, which is disruptive technologies, and then also showcase some of the work that has been done at NED University with specific reference to what actually Dr. Lodi talked about. In fact, if I may take this opportunity to say that 90% of my presentation is already done, because Dr. Lodi, without anything, have explained what actually we have been working on, and that exactly aligns with the concepts and developments in the disruptive technology. So let me share just So when we talk about this is a small brief outline of what I'm going to discuss today. I'm not here to teach, of course, because I assume that much of our audience would be pretty much aware of what we mean by disruptive technologies. But then I specifically focus on my title, which are smart and immersive technologies in case of disruptive technologies and their scope or future dimensions in construction industry of Pakistan. Primarily, what I'm going to discuss is all those things which we have already done or are under development through different R&D projects and through different industrial projects. So I will briefly talk about disruptive technologies, then smart technologies, and then few case studies that we have conducted with respect to application of smart technologies, immersive technologies and its application, and a little bit of framework guidelines, majority of which what Dr. Lodi and General Harun have discussed in their introduction, and Dr. Lodi in his talk. So when we talk about disruptive technology, actually this idea is driven out of disruptive innovation. And this disruptive innovation idea was put forward by a system designer, Clayton Kinston, if I'm pronouncing his name, and he basically focused that any innovation that disrupts your normal routine, normal working, the normal way of working of any organization or any profession would basically be termed as disruptive innovation. So that would result in change, and of course that change has to be adapted and adopted by that industry for the benefit. Now, it's not just for the innovation for the sake of innovation, rather the innovation that basically benefits the industry's consumers, the industry itself, and the supplementary, or what we may call as the sister businesses that operate with respect to that particular industry. For example, in case of construction, so there are a rough estimate is that around 45 to 50 different industries basically depend upon the construction industry. And hence anything that becomes disruptive in the construction industry for positive sense would also disrupt the normal business routine of the sister organizations or sister industries. A disruptive technology, of course, would try to sweep away any habits, any existing system that might have been there for a longer period of time. And hence, it requires a more educated, more R&D related effort to incorporate such technologies into normal businesses or normal routine business. Because as the word reflects disruptive, so you are disrupting the SOPs, the modus operandi that have been there for a longer period of time. So human resource, the equipment requirement, maybe the technological requirements may require a overhaul in any business requirement. Now, when we say that, so it might sound that it would be very costly. That is not the case with the invent of the computer, as Dr. Lodi was explaining, because nowadays it's not very, these technologies, which like computing technologies, like they are becoming cheaper and cheaper, and hence and also accessible, and hence that has made sure that even a startup, small startups with limited resources can get into this disruptive technology business by inventing an entirely new way of something to be done. That is why in recent past, the entrepreneurial funds have also been focusing on entirely new innovations, whether it be small, but their impact area should be larger. Say, for example, a lot of innovation that have been done in construction and other industries, like these cloud-based mechanisms, these carpooling companies which we have, and likewise property dealing companies, they base their businesses on disruptive technologies, but those technologies that are not very costly to implement because of the advent of the computer, and also because of the accessibility to such technologies. Now, that has resulted in revolutionary changes in the market. And that is why we see the rise of ICT and the use of ICT in general, and in particular, the sharing-based mechanisms all around the world, whether be it construction industry or any other industry. Sharing, by sharing, I mean sharing information, of course. So typically, the disruptive technologies, if we relate those to construction industry, the ones that are classified, there are 9, 10 different technologies which are classified as being disruptive technologies for construction industry, starting with the 3D printing, virtual reality, robotics and automation, artificial intelligence, because whatever data you collect, you need to process it to minimize the errors. So artificial intelligence, machine learning, use of drones or UAVs, unmanned aerial systems or aerial vehicles, 5G technology, which is at the doorstep of, which is already incorporated in many countries who have developed it advancedly, like US, China, but it would be at our doorstep, it's almost at our doorsteps as well. Cybersecurity development. So when you work in IoT, when you work in ICT, so a lot of cybersecurity issues also arise. And hence, to cope up with those issues, there have been significant development in cybersecurity as well. Augmented reality and IoT applications, as I discussed. So these 9 technologies are typically classified or categorized as being the disruptive technologies when it comes to construction business or construction industry. Now, when we specifically talk about smart technologies, which is one part of my presentation today. So smart, the word smart is typically termed as self-monitoring, analysis, and reporting technology. So anything that ensures kind of self-monitoring, any technology rather that ensures self-monitoring, that enables analysis by the data that is collected through that self-monitoring, and also report, and even further, to further extent, when you integrate that to artificial intelligence, providing you with the solutions, would be termed as a smart technology. Typically, smart technology, as I said, utilize artificial intelligence, machine learning, big data analysis, or big data analytics to provide certain decision-making outputs, which we may call as cognitive outputs, so that your history of working, your way of working could be integrated with the best possible manner. That is technological benchmarking or data benchmarking, and can result in better solutions, error-free solutions, and error-free decision-making. Examples of a smart technology, typically when we relate it to construction, would include IoT, smart connected devices, and smart devices. And all of these have been and are being utilized to a certain extent in construction industries around the world, which we may term as the developed construction industries. Even in our country or in developing construction industries, there have been certain applications. But of course, the full-fledged understanding and awareness and human resource requirement have been something which have been compromised over the years. And that is why forums like these may generate awareness and may create such rolling ball and effect that can result in further development in this area in our country. Now, smart technologies, basically the application side, which we typically see are smart cities, IoT-based, sensor-based concepts. These actually are from our own project, sensor-based data for energy efficiency. I would explain it a little bit. And also, as we said, for smart monitoring of the sites, for smart monitoring of the construction process through UAVs and through cameras and etc. Now, it's not about just getting the videos out of that camera, but also to process that data. And that is what I'm going to discuss with a couple of examples that I'm going to discuss in future slides. Now, let us go through the first case study. And actually, this is one of our projects. This is also already published work, in which basically we developed smart progress monitoring of building construction elements using an integration of videography, MATLAB for data processing, of course, for training of data, and BIM, building information modeling integration. Now, the very concept was that although there are different technologies which are available for smart monitoring, like laser scanning, like drones, but sometimes these technologies may have a wider cost impact on the construction companies, and hence they may refrain from adapting such a change. It's not about that typically industry or the professionals might not be open to such change, but when it comes down to the adaptation of such technologies and its cost side, and of course its human resource capability development side, they may refrain it from, and they might be looking for either going through the traditional ways, or they might look for some kind of low cost mechanisms, because it is very important that when you introduce disruptive technologies into any industry, specifically in developing countries and developing industries like Pakistan, the cost is one of the biggest arguments to justify the acquiring or development of a technology and then implementing it on a construction site directly relates to business profits, directly relates to competitiveness of business in our industry, which is typically a competitive bidding based industry. So that is why in any such innovation, the R&D people have to ensure that such technologies are developed, number one, using already available tools which may not have been used for smartness, and then secondly, they remain cost effective. So keeping in mind that, what happens is that we basically utilize videography data to analyze and this small video clip would explain that we install site monitoring cameras on site, then you can get the CCTV footage of that and also transform that video through the Wi-Fi which is provided on the site, which is not any scarce commodity anymore. And that video is basically processed through the MATLAB interface, which we have coded ourselves, where image processing happens. The image processing can give us face detection as well as progress reporting for whatever has been done so far at the site as compared to what we had planned. So in a nutshell, the integrated framework works like this, that the camera provides the feeds are transformed to our workstations at a lab, and then those feeds are processed through the MATLAB integration to provide our progressive reports as well as face detection of what has happened. So it provides a better visualization, better progress monitoring. So if we move on, for example, this is a case that we implemented at one of the academic buildings at NED University. So we worked with a single camera. This is a simple IP camera, which is available like at very cheap cost, maybe between 3,000 to 5,000 rupees, even cheaper. And this, when it is installed, that 360 camera on the site, this is the location of the site. So you have to calibrate the site, of course. You have to calibrate it for the elements that are to be monitored. We basically monitored 3 elements that included the vertical member, that is column, beams, and block masonry. We call them as bulk activities. So the camera is installed, the calibration for the camera and its pixel is done, and then accordingly, if you look at the plan, so this is the whole building plan, we marked and we calibrated the grids with already developed as planned BIM model. Now, once it is developed, then this MATLAB interface is designed where the live feed could be incorporated, and live feed comes in the form of either you can take a picture of it or you can utilize the video, and accordingly that live feed automatically starts giving us phase detection in the form of colors. So yellow, blue, and green basically reflect different elements such as formwork with respect to its color coding and concreting that has been done. So it provides a visualization. But the more important point is that we can analyze this data set by drawing different. So this, for example, picture is converted into grayscale mode. Then we basically select our region of interest. That region of interest is isolated in the analyzer from the picture that has been got through the feed, and it gives us the quantity. It gives us with respect to the calibration of how much quantity of work has been done. Then, because we have already have an as planned model in building information modeling platform, we can compare what was planned with what has actually been done on the site. Now, this provides us as planned versus as built volumes, and accordingly percentage of work that has been completed. Now, what is the advantage of this whole system is that when we take it through the video cameras live feed through this IP protocol, then there are lesser chances of getting it erroneous data, because when we get it through human resource, they might have errors, they might compromise on the measurements, and hence the actual progress might not have been reported. Secondly, it is kind of a field and head office integrated framework, which will provide us greater flexibility in monitoring a site as well. The data collected through this camera is an evidence-based data, so it would reduce any, or it would avoid any conflicts that may arise in the billing phase of the project. And accordingly, when we are monitoring the site, so there are multiple other analysis that we might be able to do. So data collection and error-free data collection is the key to this technology. Another point is that sometimes we hinder because of human resource availability or human resource capacity to incorporate any technology into our environment. So another idea was to progress monitor with whatever resources, human resource available at the site. So a simple, all of us know that surveyor is present on the site. So the idea was that how can we do the productivity tracking of any construction work? So what we did was that we thought of utilizing the already available surveyor on the site and the normal total station, which could give us geodetic points, and those points could be utilized through building phase surveys and could be utilized for developing as built data-driven models in building information modeling environment. So again, this study was implemented at our business incubation center when it was under construction a couple of years ago. And what we did that this whole framework was applied onto that building. Now, the as-planned model in BIM, whether it be structural, whether it be architecture, was developed. And then a normal total station was used to perform building phase survey, through which the geodetic coordinates were gathered, through which the CSV files were gathered. And these files were uploaded to the cloud from the site, which is not any issue nowadays with Wi-Fi technology. That cloud, basically then the cloud-based data was programmed for developing or generating data-driven as-built models in through Python programming, which is supported through different packages in building information modeling platforms. And hence, if you see, there are two progressive updates for columns, slabs, and block masonry, again, the bulk activities for the building. You can see that these progressive updates provide you the as-built model in Revit using the surveyed data, which was transformed through cloud. So survey cloud BIM integration with the advent of this cloud technology, with the availability of this Wi-Fi technology, can very accurately transform raw survey data, which was just numbers which were just numbers few years ago, into a 3D model, into a data-driven 3D model. So this is, for example, a whole building, and accordingly, you can generate the whole building as planned model in 3D as well. And with that, the data could be analyzed for productivity tracking. These are certain productivity curves. According to, for example, this blue curve shows you the typical productivity data for the industry for concreting of slab. Now, according to our planning, the red line would show is showing us in the graph the productivity benchmark, and we can monitor the productivity data by taking the schedule of quantities from BIM for the data-driven models that have been generated and comparing it with the as-planned model, which was already there. So again, this technology would not require the companies, small to medium-sized, specifically construction companies, to incorporate a lot of new things onto their sites and into their office. What they need is, yes, human resource training, but the simple surveyor who was there on the site now can provide you a lot of valuable data, which you can utilize for monitoring and progress of the construction project site. Now, advantages, as I already discussed, one of the things which I would like to mention very quickly is IoT based. We are working on a project which is funded through HEC as well, in which we are developing guidelines for energy efficient housing. Now, what we did was that we understood that it's not about just having the bill data, the energy bills data, electricity and water and gas to analyze that. The simulation is not enough as well. We need to incorporate the habits of the people who are living in that house. And for that reason, we basically designed certain sensors which can monitor different energy aspects, energy performance aspects of a house. And we incorporate these sensors into the house for a period of 15 days to 30 days, from where we get the live data set in the form of graphs and charts, and we analyze them and compare it with the simulation results. So it incorporates what we call as living lab concept, in which people are living somewhere. We are utilizing the IoT sensor base, which basically provides us the data set to the cloud, and we analyze that data to utilize it for better energy performance of a house. And it incorporates the habits specifically for those kind of buildings which are currently in use. So this is again one of very key areas of disruptive technology that could be applied in construction industry. Now, when we talk about immersive visualization, typically the categories of immersive visualization is anything in terms of illustration and diagrams, images, 3D images, which basically communicate something about that project, about that idea. So immersive visualization typically is classified into 4 categories of visualization generally: mixed reality, virtual reality, augmented reality, and immersive visualization. The place where I'm sitting in right now is basically NED University Virtual Reality Center. It's a first of its kind facility anywhere in South Asia, where we have multiple systems related to augmented reality, virtual reality, passive 3D visualization, virtual teaming, and drones, etc. So it's not just construction related, it is university level center, but we are working on a lot of construction related projects here. I'm heading this center, which was envisioned by Dr. Lodi way back, and we took a lot of time and we got it designed, we designed it to the optimum requirements, not for just current time, but for future time, say for 10, 15, 20 years from now on. And we are developing it through R&D, through different more technology development and procurement. When we talk about augmented reality, there are or immersive visualization, there are many applications. If you see all of these pictures are typically from our own projects, so it could be utilized for construction planning. Augmented reality is well utilized around the world by the architects for better visualization of the things, for cost planning, for infrastructure management and infrastructure visualization. Let me quickly go through what we have done. So this is one project that we did with an American company, in which we integrated the drone-based data with the data set of laser scanning, and integrated these visualization with the BIM model into virtual reality. Now, we presented it to MassDOT, who were basically, this project actually was in Connecticut. The whole framework was this. We worked with AI Engineers USA on this project. They basically took our help in developing the integrated visualization. The basic idea is that the drone-based data, the laser scanning data, and the building information modeling data provides us different dimensions to a infrastructure facility. And if we can integrate those into virtual reality, it can help us in better visualization, better as-built model generation, better decision making, and inspection in future as well. So what we did, for example, this was a Connecticut Waterbury bus storage area, which was almost 400,000 square feet area, 2-story facilities on 30 acres. And the whole building, the AI engineers were responsible for planning and monitoring and management of this project. So what we did was our partners utilized the drones. They are very well versed, and laser scanning data to generate different models. You see this drone video at the bottom, which is basically reflecting one of the flights. There are many routines in utilizing UAV-based data collection, and then laser scanning data was collected, and this is the laser scan model of the same facility. you can see the accuracy of laser scanning. Basically, sorry, this is UAV visualization, and I'll show you so this, a number of pics, a number of what we call as point cloud data was generated out of the UAV data collection, that is using the drones. Thereafter, the laser scanning was performed mainly to look for the inside of the building or the detailed features of the building, and this is the laser scan data model for that very facility. After this, we have the data set for in terms of drawings for the as-planned model. So we developed the BIM model as well. So the BIM model, basically as-planned model was developed. Now we had 3 data sets: BIM-based data visualization, UAV-based data visualization, and laser scanning-based data visualization. Laser scanning is very good for as-built.
Short rakhega, please.
Sir, I'll just finish in 30 seconds, 1 minute.
Okay.
So what we did was we were able to integrate it into for integrated visualization as well as decision. This is the screen recording, of course, of one of the session. I wish I could have shown you it in virtual reality or augmented reality. But you can see that the measurements could be done of the site. The outside of the site was UAV-based data set, and decisions could be made in this model in virtual reality. So at the moment, for example, 2 personnel were integrated and talking about different decision parameters and measuring. Another thing was that we utilize virtual reality for capacity building, which was main point for engineers. So what we did was we developed this NIPA bridge, very famous in Karachi, at NIPA Chaurangi. We developed its model in virtual reality and 3D model. We developed as a build model, and as well as we developed certain cracks and physical deterioration parameters for training purpose of the engineers. Once the model was developed, it was geodatically placed in the area of NIPA, utilizing the Google images, utilizing the GIS, and then after the model, it was tested on number of engineers through test sessions, and you see that the data was analyzed for their comfort level. Overall, the feeling of the system, the use of the VR gadgets, the overall comfort in visualization was rated very high by the engineers in that sense, that this technology, which is virtual reality, could provide decision makers with a better visualization for infrastructure management, infrastructure decision making. Finally, very quickly, and I don't need to stress on this, what we need to do is the keywords. We need to incorporate capacity building for having disruptive technologies incorporated into construction industry. We need indigenous solutions. We cannot just adopt solutions from outside. We need to develop indigenous solutions which are cost effective, which could be implemented using limited resources. We need R&D investments, which was highlighted by General Harun, that sometimes we refrain from having substantial amount of R&D investments. Generally speaking, we need to have certain linkage in industry academy, in which industry becomes a solution seeker while academia becomes solution provider, because R&D environment is, of course, everybody would understand that there are more opportunities for R&D in the academia. Adaptability towards the innovation and disruptive innovation should be increased through awareness sessions like these. And finally, curriculum update, Dr. Lodi already talked about it, but finally, I would stress on one important point, that when it comes to policy implementation, knowledgeable, open-minded, open-hearted, innovative, and R&D oriented minds should also be incorporated into explicit roles of decision makers, whether it be positioned at the policy making organizations or whether it be some regulatory agencies. And that is where we need to, because at the end of the day, incorporating a technology into an industry would require regulatory changes, would require policy decisions. And for that, we need to have right people in the right positions. My apologies for taking a little bit of more time. Thank you very much. I'll be open to any questions later.
Thank you very much, Dr. A very comprehensive presentation, and particularly your case studies. You talked about self-monitoring, analysis, and reporting technology. Frankly, I didn't know. I thought smart means just a smart as an English word. So this is a knowledge to a layman like myself. And you talked about the case study of smart progress monitoring using videography, MATLAB, and BIM integration. And you have covered real-time productivity monitoring, energy efficient assessment, and your high point was the proposed policy framework. And we will include this in our report, which will go at the appropriate level, inshallah. And but the key point of your presentation, which touched my heart, was that you require people with technical knowledge, but with open minds and hearts. So this is the connectivity of your technological knowledge and with hearts and minds also. Wonderful, sir.